Welcome everyone. Thanks for coming to this seminar. I'm sorry that we keep you waiting because we have some technical problem. We are glad that we have Peter Leeson today to give us a talk. First of all, I would like to thank Ouyang, our old friend, for introducing Peter to us. Peter himself is a director of Leasing Group, a company that working on the renewable energy solution development. And Peter himself is a renewable energy project developer and building integrated photovoltaic specialist. He has expertise in both utility scale photovoltaic, including solar farm develop, design, and construction, as well as residential and commercial PV application. Here he will talk about the BIPV experience, research, and insights of himself. Let's welcome Peter. Thank you.
Thanks everyone, thank you for the intro. I'm impressed that you remembered all of that without looking at the script. I'll be completely opposite today. I've written a lot of details down and I'm going to be referring and looking at that a lot, so please bear with me. So basically, what I'm going to be talking about today is the practical applications of building integrated PV in a real world environment, both facade and roof mounted systems. I'll outline the levelised cost of energy of some systems that we have actually built, installed, designed, so you can understand a bit about the market barriers. The US solar tile market is expected to reach a value of $895 million by 2025. And the global forecast of BIPV is forecasted to be, in 2028, $8 billion. So the BIPV market is looking to grow. It's a very, very tiny, uncommercialised market at this point in time. I'll outline the advantages and limitations of BIPV and showcase some successful installations through case studies. And I'll show you the technical challenges that we face to actually implement these projects around the world. I'll present a plan for manufacturing in Australia. So a big part, I'll introduce a bit about myself in a minute, but a big part of what I am is Australian manufacturing and holding the IP here in Australia for Australian jobs, but just growing the technology as a home base and actually being able to execute it here and export to the rest of the world. So who am I? I'm the founder of Leasing Group. So Pete Leeson, obviously, Leasing Group. It wasn't much talent to actually think of that name. We have a diversified number of businesses underneath what we do. Started out in business when I was 21 years old as an electrical contractor. And our first project that we worked on in renewables was a wind farm in 2007. I started in solar power in 2008 and quickly realised the challenges and objections of solar panels on roofs. So in the very early days, before you would see solar panels on everyone's roofs, you would basically get a lot of objections from homeowners saying, I don't want to see those on our home. Now it's a bit more acceptable. I started selling BIPV products in about 2010, and I started to understand the errors and challenges around all the aspects of building integrated products, whether it's facade, windows, or solar tiles. In the early days, I decided to start designing solar tiles in my spare time. So I thought there was a better solution and an easier way to do it. So I taught myself 3D modelling and started designing these different products for different types of roof profiles. In 2015, the business diverted slightly to solar farm development. So Leasing Group as a business has developed 150 megawatts of solar farms in Victoria, 3 large projects. Our largest project under development is a 440 megawatt solar farm. So it's 1,100 hectares of solar panels and an 800 megawatt hour BESS. 2 of our projects have successfully been built. One's under construction right now, and we've got a pipeline of about 1 gigawatt. So our main business to date has been solar farms, and that's how we have basically funded our hobby of solar tiles and BIPV, because at the minute it's still yet to be properly commercialised. We also run a residential and commercial solar business. It's called Leasing Solar. It's mainly focused on bespoke system design, but without actually having the hands-on experience of construction, sales, marketing, understanding standards, compliance. We've got team members that are on standards committees and installer reference groups, and as such, we don't know how to execute and design a product to suit the market for BIPV. So about 8 years ago, I continued the development of our solar tile, and last year we launched Volt Solar Tile. It grew off our balance sheet, so it's a privately held business. We've developed the highest efficiency solar tile in the world. Launched in October last year, 19.5% efficient. We're now installing projects in Europe, Middle East and Australia, and we're about to enter the United States. We're just going through our notice of acceptance testing. So BIPV Applications, I thought I'd start with this project because there's common misunderstanding that things like walkways and solar carports are built integrated PV. But under the National Construction Code, they're not a class of building, they're just a structure. So I don't talk about these types of shades, car park shades and walkways at all in my conversation, and just consider them to be standard modules with a different type of mounting system beneath them. So the applications are going to talk about, the top left you can see solar glass windows and facades. Well, that's a facade. To the right you've got solar skylights, and then you've got the solar tile on the bottom left, and then you've got your coloured glass, solar glass windows. So this is a little bit 101 on system design and PV generation, but this is a summer solstice in Melbourne on high-rise buildings. So this is CBD. And what it shows you is the shading, and I'm just going to pull that back again to the start. So it shows as the sun rises in the east in the morning, and this is summer, so the sun's going to be slightly behind us, and you can actually see the shading on the building. So you can see that the sun's coming up and the east is exposed to the sun. And then as the sun comes through the middle of the day, it comes back down over to the west, and we're getting sun on the west, but there's no sun on the east of the building. And the front of the building the north gets very little sun. So this is if you were to put a facade system on there, you need impact of direct sunlight to those solar cells to energise them, and that's a challenge. So if you then look, sorry, that one was the winter solstice. Let me go back again. The summer solstice, as you can see, so the north is very dark, following through to the west, and then you can see only for a small part of the day you're actually getting any sun on the north. So if you were to install solar panels on the north of that building, they're going to get very limited sun in summer. But then if you go through to the winter, you can see you're going to get better irradiance. But if you had a building in front of this, you're going to get shading. So it's following through from the east, you're maintaining sun because it's coming around to the north of the facade and then around to the west. So it's just, I'll touch on this more later, but the direct sunlight. So that's 101 design when you put in solar panels on the facade of a building and the issues and impacts that it can have. So solar glass windows, there's two different types that I've shown here. You've got thin film, solar glass, and then you've got Clearview. Now Clearview is not necessarily a type, it's a brand, a product that's been invented, which is very, very interesting. So first I'm going to start on thin film solar glass. It's a 6.6% efficiency and it has 20% light transmission. So light transmission is very important when we're talking about solar glass windows, obviously. The more light, the better for the window, the less the not. Clearview solar glass has a 3% efficiency and 70% light transmission. So you can see the difference there. I put this graph together to show what happens with thin film solar glass. So basically you can see on the left of the module of the graph, you've got 95 watts down the bottom, and you've got a 20% transmission, and the blue line is the efficiency of the module. So the thinner that you make that solar cell, the more light transmission you're going to get through that thin film. And the higher the light transmission, but the less energy. So you can see the energy taper, the efficiency tapers off in the blue line as you get more transmission of light. And if you were to push the limits to get down to 2 or 3%, you're getting very little. You're getting higher light transmission, but far lower energy out of the product. For the Clearview product, however, it's got a film that sits down the middle of the glass, and that film transfers the light down to the bottom of the edge of the glass, and that's where your photovoltaic cell is. They use a crystalline cell, and the technology is basically in that film for the output. They've got a 70% light transmission, but a very, very low efficiency. So basically the challenges with solar glass, low efficiency and performance, a large amount of of electrical connections. So within a system, if you're talking about having a 30 watts per square metre and you've got a 1 square metre glass window, you're going to have very limited energy generation. You're going to have a lot of electrical connections. So 7 times the amount of electrical connections. It's 3% efficiency versus a standard module at 21% efficiency. That's seven times the amount of connections. So it's the time of work for an electrician to install, and it's also 7 times the amount of problems that you can have. Electrical connections not fitting, points of failure, basically. Engineering system, as you all know, I'm guessing we're all engineers here, that you want limited points of failure. If it doesn't need to be there, you remove it from the system. So here's a calculated graphs of performance of a system in Melbourne CBD. And you can see a 15 kilowatt system that would be sitting on the rooftop of a building facing 22 degrees. You can see the energy that it would be generating. Now, this is a design, so this isn't real world conditions. If you put that on 90 degrees on the front of the building, not accounting for any shade, you're going to get a calculated reduction of 35% of the energy generation. Now, we've done system installations actually on the facade of a building in Richmond. So we've got a building integrated facade, which I'll show you in a minute, and then we've got a sun power system that sits up on the roof. The performance is actually a reduction of 52%, and that's still with very limited shading. So in the real world figures on a facade, you're getting far lower generation than what you're getting out of the standard system. Okay, so BIPV facades. So this one here is a system that I was talking about that we installed in Melbourne. BIPV facades are basically curtain walls. There's solar modules mounted on the side of a building. So a curtain wall is generally a glass facade on a building, and instead of using standard coloured glass, you use photovoltaic cells within that glass or photovoltaic modules. Some projects have just got standard modules on the side. Some do frameless and they install a custom mounting system. But again, you've got all the issues that I spoke about with the solar glass, being that you're facing 90 degrees and you've got the extensive electrical connections included. So access, as you can see here, this is a system that our team was installing. You can see the curtain walls are installed using aluminium extrusion on the top and the bottom. Instead of using the coloured glass, we've just changed it to a thin film, but it's a completely customised system. The structural silicon process required to do this needs to be done in a factory. So if you've got an extrusion system where you've got a cap in sitting on the front of it, that actually fixes the glass back to the building. So that doesn't need to be structurally siliconed. You can actually use a double-sided tape for that system. But once you go to the building standards, once you want to remove that cap, and if you want a seamless glass face of the building, it actually needs to be structurally siliconed in a factory, and it needs to be pull tested. So they batch test, I think it's 1 in 7 or 1 in 13 pieces of glass. They actually have to pull test to make sure it's adhered properly. So you build it in sections with aluminium on either side, and then you sit it inside the trunk in on site, and it just clips in and fixes back to the building. A big challenge for the curtain walls is that you've got a glazier on site and an electrician on site at the same time, or multiple, and they have to work within each other to install the cabling and all the systems within there and actually get it finished off and compliant. Aside from the fact that, which I'll touch on in a minute, that none of the Australian standards for electrical installation or PV account for building integrated PV. It's not considered whatsoever. So as soon as you start trying to put cabling as such inside the building envelope or the fabric, then you've got to have heavy duty protection and this sort of stuff. So a huge challenge that has come with all integrated systems is the actual combined trades that you need on site and the delays and costs that cause. So not only the product's more expensive, but the actual process to install is far more expensive. So wiring. So this is a photo. This is a completely custom system. So when we made the extrusions, we actually put a cable containment system in behind the modules to enclose the cables so they had heavy duty protection. Under AS 5033, you're not allowed to have DC cabling above ELV in the walls. So you can't, or in the roof space. So basically it has to be in heavy duty conduit because it can't be isolated. Whereas you put a power cable in a home that's AC, it's protected by a safety switch, it gets cut, someone actually accidentally breaks it, it'll trip off. And even if you haven't got a safety switch and you've got a circuit breaker, it'll still trip if there's a short. Whereas with DC, the sun's shining, that cable breaks down or gets pulled apart or becomes live, there is nothing there to turn it off unless you've got microinverters or optimizers or solar edge up on the roof. So the reason that standard's there is to protect the cables, but it creates many challenges when you're actually installing a system where all your string and array cabling is going inside the building structure as well. Isolation, so very interesting one. AS5033 requires an isolator be within 3 metres of the array and visually accessible. So if you've got a big glass facade on a building, you have to have an isolator that if you're standing in that array, it's visibly accessible and it's within 3 metres of the array. Now, I don't know many people that would climb up onto the side of a building and to switch something off. So again, it doesn't make much sense. But for this project, we actually installed the isolators on the rooftop. So it was in behind the parapet, correctly labelled, but we had to get an exemption from Energy Safe Victoria to do this. So we had to get an exemption to make it safer and more accessible as per the rules. And that process takes about 6 to 8 weeks. And that's if you've done it before, you know what you're doing and it's well documented. So, and it's got to be done on a project by project basis. You can't, to get an exemption, it is that specific address and project that you need to do. So if you do this multiple times, you either need to go through the process of standard changes, which takes years, or you have to get an exemption for every project. So I'll touch on the business case of this project. There's a quick bit of footage before the cladding was finished, but that you can see the actual project itself. So you can see that there's just silicon gaps between the modules and there's no capping on there. And it looks fantastic, it does, and the finished product looks even better. However, it's a very expensive product that generates very low electricity, as I'll show you. So the total cost of the system for the PV component only was about $18,000. So that's just a 6.16 kilowatt system installed on a facade for $18,000. The extrusion installation was $26,000. Now, your standard extrusion installation for this might normally be $15,000 to $18,000, but obviously because of the costs of being completely customised and having a tie-in with the electricians on site, it's slightly more expensive. So $44,000 for a 6.16 kilowatt solar power system on the facade. Energy generation, whereas this system should probably be generating, if it was a roof mount, about 140 megawatt hours or 140,000 kilowatt hours per year. Over 20 years, over 20 years, this system's going to generate 76,800 kilowatt hours. So as I said, the reduction in performance is by about 50%. Simplified levelised cost of energy, no maintenance. So just on the solar alone, the levelised cost of energy is 23.4 cents. So you can see it's very expensive electricity. Yes, it's an architectural statement, very expensive. If you add in the facade mounting system, the system's 57.3 cents per kilowatt hour of electricity that it generates. So facade systems are not only challenged by the low energy, they're challenged by the installation and then the ongoing maintenance and operations. So for that reason, our business does not promote or try to sell facade systems. We did for many years. About 8 years ago, we dealt with a lot of the challenges. We've installed 200 kilowatt systems in Southeast Asia that have 2,000 panels wrapped around a facade. And it's a lot of work, but ultimately they don't generate electricity and we can't see any way for it to be commercialised. It's an architectural product and it looks great as an architectural product, but inherently it comes with a lot of issues. So Volt Solar Tile. So Volt is part of the Leasing Group. It's a 100% owned product and business that I introduced before. And it basically looks like a standard roof tile. It's the most efficient solar tile in the world, being 19.5% efficient compared to what would be a standard module, which is 21% efficient. And as I introduced before, it was launched in October last year and we've already installed systems here and in Europe and we're distributing to the UK and Middle East as well. I'll touch on the specifications slightly, just a little bit on the product. I won't go into too much detail, but basically the solar tile is, the Planum solar tile is made to match a Planum roof tile by Lascandea. Lascandea is a Spanish roof tile manufacturer. They make a terracotta roof tile, one of the highest quality roof tiles in the world, and they distribute to 85 countries. And why did we make a solar tile to suit this product? It's because there's already an existing market for our roof tile. So they're distributed in 85 countries and one of the world's largest roof tile manufacturers. So it means that we don't need to convince a homeowner, a builder or a re-roof to select a new roofing product. We just integrate with their product as you would a standard roof tile. Instead of having the roof tile there, you have our solar tile. It's 1723 millimetres wide. It's 445 millimetres high in terms of the product, but only exposure of 365 millimetres. So the batten spacing of roof tiles determines how much of the face is exposed to the sun. So if your batten spacing is 365 millimetres, you'll have 365 millimetres of roof tile exposed to the sun. We've gone with a very wide product. A lot of the products in the past are very, very small. So there might be 1 or 2 or 3 roof tiles wide. But that increases the amount of electrical connections, it increases the amount of cuts, the junction box, connectors, so all points of failure, but it also increases cost to do this. And that's such an important thing because today, building integrated PV has been very expensive and our aim is to bring it as close as possible to standard roof mount systems. The second solar tile that we've developed is the Lodge. And the Lodge matches a bridge tile roof-in roof tile. So it's a concrete flat roof tile. Both our profiles are flat roof tiles. Bridge Tile is owned by Brickworks Group, an ASX listed business. They manufacture their concrete roof tiles here in Australia. So again, why have we chosen to go with Bridge Tile? Bridge Tile know every builder and architect in Australia, and therefore they've already got a roofing market here. So we don't need to tell a homeowner like with a builder, like with a Tesla roof or a new lock or a track tile, that you need to buy a new roofing product and a new solar product. You're buying an existing roofing product from a known trusted brand. But instead, we just add in our solar tile and the roof still gets signed off as a roof. The Lodge, again, it's 5, so the Lodge roof tile is slightly wider, it's 300 mils wider. So we've gone 5 tiles wide. And the reason we've gone 5 and 7 exactly to those dimensions is you've got to find the nearest point at which your cell sizes will fit within the solar tile, but it still meets the same width as a roof tile. So it'll be in multiples. So as we're 7, we could probably halve the size and go 3.5 solar tiles, but that doesn't work, but our solar tile would be half. But if you want to add 1 more cell row into your solar tile, it's not going to match any roof tile width, and you're going to have a big blank space of glass and extrusion on your module. So hence the 5 and the 7. A redesign, and this product was redesigned many times over 8 years, but the going to the larger width created a lot of problems because roofs aren't built straight. And it's not an engineered product, a roof. It is literally timber that's put on by carpenters on site. And so they're very wavy. So if you put a 1.7 metre wide solar tile on that roof, you're very likely going to have a 20 mil gap between the solar tile, the roof tiles below in the corner. And gaps in roofs create water leaks, which defeats the whole purpose of a roof, which you can't do. So we've got a patent for our product in which the top extrusion of our solar tile interlocks with the bottom extrusion of the solar tile above. So when you slide it in, it clicks in and it locks down and holds it onto the roof. And it solved the problem of building integrated PV leaking on the roofs. So basically we've got a product that's far more weatherproof and waterproof than a standard roof tile. But these are the little intricacies that you need to think about from an installation perspective. It's okay to go and design a product and then commercialise it, but if you can't pass your dynamic weather tests or your wind-driven rain tests, then the product's going to fail. And ultimately, it might be a great PV product, but it's going to be a terrible building product. So you've got to have a consideration of both. So as you can see, this is a rendered picture, but it's probably one of the best we've got. The solar tile just integrates directly with the roof tile. So you can't, I mean, from the ground, you can barely see it. If you've got a very shiny day, you'll get reflection off the glass. It's a different material rather than a terracotta or a roof tile that absorbs more sunlight, and obviously the glass reflects it. Access and installation. So the access and the installation of, and this is a project that we did in South Australia, it just gets laid like a standard roof tile. So in the new home build process, it's not a retrofit product. To make a product that can be retrofit onto existing roofs would be very, very difficult. basically impossible because your batten spacings, your tile widths, all this sort of stuff come into account. So it's got to be done and installed on site. But basically you lay your first couple of roof tiles and then you lay your solar tile and it gets screwed down to the roof. So very simple, easy process to follow where the roofers and the electricians can support each other. But more importantly, the electrician can do their job very, very quickly and get out of the way of the roofer. A roofer will lay a 250 square metre roof, 6 roofers, in 1.5 days. It's 250 square metres of sarking, battens and roof tiles, finishing ridges, mudding all the ridges and the hips, and they're out of there in 1.5 days. So if an electrician takes an extra 4 hours to install one roof and delays that roof tiler, you've got a crew of 6 people that don't want to be there. Additional costs again. So the whole installation, sales, marketing, installation process of building integrated materials is so important if you want to remain competitive. Wiring and cable containment. So as discussed before, AS5033 requires us to have heavy duty protection of all DC cables above ELV in the roof space. This is a challenging thing to do, and pretty much no product to date has actually found an appropriate solution, and they've just been installed non-compliantly. So in this video, and it's pretty hard to see there, but you can see as it moves around, you can see the cable on the back of the solar tile, and then you can see there's our trunking system. So what we've got is an integrated cable tray within our solar tile, which contains it. So you lay one solar tile, you plug the next one in, you push them together, and then it's fully contained, encapsulated cable in the roof. So if there's ever a problem with that connector, it'll go through the earthing system if you were to get a fire. An earthing system, you get a fault and you'll be identified straight away. But ultimately, we've got full protection of our cable and it's fully integrated. So it's again another little hurdle that we've had to overcome. Installation barriers. I spoke a bit before about installation barriers in the market, and what we've tried to address with our solar tile and the development of all our products is the entire process from sales training, installation training, and so on. So many products have been brought to the market, including Tesla right now in the US. It's just getting sold direct to the consumer. So it might be that solar company's turn around saying to the builder or the consumer, we're going to sell this product direct to you. And then we're going to get a solar company to install a solar component and a roofing company to install the roofing component. The issue that comes from that is that you don't get buy-in from the trades and the companies to actually go and execute the product. So part of what we've done is we've created a Vault Partner Program. And the Vault Partner Program, it's all about training and buy-in of companies. So what we've done is we've partnered with 100 solar companies around the country. And those solar companies, they're experts in solar. So they go to the builders, the re-roofers, the developers, the architects, and they sell the product. So we've got 300 people around the country that can go and sell, and they're trained in how to sell Vault because it's a very specific product. It's not sold like a standard solar power system because it's a roof and a solar tile. Then these solar companies also have their own installation and engineering crews. So that means that they're fully trained to go out and do the installation, and they can tie in with the build programs, which is a big challenge, to not delay the builder, because the roof is a milestone payment on a home. So if you go to get your home built and they finish the roof, they'll turn around the bank and they'll say, okay, we've finished a milestone, you need to pay us. If you delay that payment by a week, you're not the builder's friend. And the builder will very quickly drop you and find another partner to go install your product. So you can't affect the build process and you can't affect the roofer's process. So having this program where we've got trained companies all around Australia and then we're implementing this globally means that we've got the total skill to full supply chain from sales, marketing and installation covered, which is so important. And additional to that, in Australia, our partnership, well, our agreements with Bristol Roofing Brickworks Group is that they're the roofing business. So a very important component of this is a solar company does not have a roofing license, or not many do. But to install a build integrated product, you need to have a license that's appropriate for that product that you're installing. So if it's a roof tile, you need to have a roofing license. So Bristol is a roofing business, they quote the roof component, and the Vault Partner is the solar business, they quote the solar component and install it. The solar company signs off on the electrical and PV side of things, and the roofing company, Bristol, sign off on the roof. And without that partnership, BIPV could never commercialise here in Australia. So this is a completely new strategy that hasn't been done before here, and it will very likely get copied by other products and other people, but ultimately, for years, products haven't been installed compliantly because they haven't been signed off by a licensed roofer. So a little on the levelised cost of energy of the Volt system particularly, and I'll touch a little bit on pricing as I go after this, but a 5 kilowatt Volt system is going to cost you around $13,000 after STCs. So that's probably the equivalent of an end-phase sun power system, a very high-end solar power system with using microinverters, maybe slightly more, about $5,000 to $6,000 more than a standard PV system. So we're still about 40% more than your standard low-range, cheap inverter panel system that you're seeing on most roofs. A 5 kilowatt system in Melbourne facing 22 degrees based on a 20-year levelised cost of energy. And when I develop solar farms, and if there are any questions later about solar farms, I'm open to those as well. But with solar farms, we base it on 30 or 40 years levelised cost of energy. But for residential homes, I just don't see the point of pushing it that far out because it's very likely that the roof will be replaced or the system will be replaced or the homeowner won't live there. So they're not actually that interested in it. But the levelised cost of energy with no maintenance again is 10.6 cents. So compared to a facade system at 57 cents, and we're just over 10 cents for electricity. So one's well above the cost of electricity currently, and one's well below the cost of electricity. Other systems, so if you talk about a Tesla solar roof, that's going to cost you about $40,000 US. Okay, so a lot more expensive than what the cost of our system, and we're about 30 to 40% less than any other competitors in Australia currently with our product. Addressable market, I'm only going to talk about Australia, but it's very important to understand what an addressable market is when you're developing and trying to implement a product into a market. So there's roughly 11,000 homes in Australia, 170,000 homes built per year, with 100,000 semi-detached dwellings. We talk about semi-detached dwellings because they're not apartments and or small homes that add-ons to homes. The NCC requirements for energy budget. So something to consider in this is, and I'll talk more about this as well. Last year, the Australian Building Construction Board implemented changes to the National Construction Code, and that were two things. We're going to a 7-star rating. This is exciting. This is really, really exciting because we're going to get better thermal envelopes on our homes. So thermal envelope, I'm sure everyone knows what it is. Walls, floors, ceilings, insulation, windows, glass, okay? And thermal members. So if you've got a big steel beam going from inside to outside your home, that's going to transfer heat. So again, that's your thermal envelope. The second part of this is an energy budget. So the energy budget is now completely separate about the societal cost of energy of the home. So not electricity, but electricity and gas, carbon, okay? And they take the space heating and cooling load, the lighting load, the pool and spa load, and the hot water load, and they add all those together. And depending on the location, the climate zone location of your home, and the square meterage, you will have an energy budget. And if your societal cost of energy, adding those 4 loads together, is more than your energy budget, you need to implement something. So you can either do that by having more efficient appliances to bring down the load, or you can have solar hot water, which is a bit of a dying industry to be honest, or you can have PV. Right now about 10 to 20% of new homes only have solar on them, okay, when they're built by the builder. Because the builder makes a 50 to 100% margin on variations when they build a home. There's no driver for them to sell solar. If you're selling a $10,000 system and they want to make 50% or 100% on that, they turn around to the customer and say, oh yeah, here's your 8 kilowatt system, it's going to cost you $15,000. And they say, well, on the telly the other day, I saw the same system for $7,000, so why would I buy it through you? So the builder's got no incentive to sell solar on the home. Instead, they'll upgrade their tapware, their sinks, their appliances, their carpet, their tiles, and they'll make 50 to 100% markup on those. So if they've got a $50,000 budget for variations on the job, they can make $25,000 out of that, whereas they're just losing money if they install solar. So there's been no real driver for solar in the industry, hence such a small uptake during the build process. But now part of the permitting process is that you need to meet your energy budget. And if you need solar to meet the energy budget, and it's still yet to be seen how much of an impact, but we're guessing between 60 and 80% of new homes will require solar because it's just going to be easier. And now if you've got a really big home and you've got reasonably efficient appliances, but you've got a pool in there, straight out you're going to need to do something. If you've got gas connected, pretty much straight away, there's a calculator on the ABCV website, which actually helps you, and I can share the link at some point too. And it's just an Excel spreadsheet, and you can put in your climate zone, your square metre rating, efficiency, your appliances, and then you can actually see what size PV system you require. So we're going to see this huge growth in the new home market of putting solar panels on. And many new homes, you build this beautiful new home, do you want to see solar panels? Maybe not. So we really believe, particularly in Australia, the addressable market's going to grow significantly. And by 2025, we believe it's going to be about $76 million for solar tiles alone in the new home market, which is a significant growth. And if Volt is a big market share, that enables the next big thing that we want to do, which I'll talk about at the end, which is manufacturing in Australia. Well, I must be getting near the end because that's what I'm talking about now. So pathway to manufacturing in Australia, a big ambition of ours is, and actually working a little bit with Ouyang on advice on manufacturing in Australia and the best way to bring it here. Being that we're exporting in many different markets, the opportunity to manufacture in Australia for Volt is very large, because we're probably going to be in the near future the only business that can export solar modules out of this country. Because if you try to export a standard solar module, our cost maybe, right now we're probably about 60 cents a watt, Australian dollars. And then you might be buying at 35, 36 cents a watt, in Australia currently for your module. So you can see this huge discrepancy. So what driver is there? And we've only got one manufacturer in the country as well, which is great, but we're never going to grow vertical integration if we don't have a large amount of manufacturing. There's never going to be a capability here, and we're constantly going to get all these brilliant technologies that this university is developing, and they're going to get made overseas, which is, it's great for the environment, it's great for the transition of the energy systems, but it's not good for Australia's economy. So the frame design. We haven't developed some fancy PV technology. That's not what we've done. We've developed a way to integrate it into a building at a low cost and build a good business model around how we distribute this around the world. So a lot of our IP is in our frame design. So when we're talking about different cells, right now we're using an MWT cell. We can use any cell. We want as dark as possible cell. We don't want to see big silver bus bars, but ultimately we can do many different things with our product. The IP is held in the frame design. To make extrusions and cut extrusions here with advanced manufacturing isn't a very challenging thing to do. So we're looking to, we've finalised our business case and we're looking to move forward with manufacturing and financial close next year. Having a dedicated manufacturing line for a bespoke product like ours is really, really important. So right now we manufacture out of a 2 gigawatt line in China. And every time that we want to make a run, they need to shut their line down for a couple of days. And then they run our modules through it for 2 days. And then they rejig their line and they start it back up again and run it again. So we're wearing all that cost, and all that cost is borne by us, because ultimately, why would they make our product if it's, they're only going to charge the same amount per watt as their own product? And the same goes for the glass. And the glass, the back sheets and all that sort of stuff, pretty easy. But so these products, it's challenging to get the cost down. So what we're going to do is we're going to have a dedicated manufacturing line that only makes our product. Hence, there's no rejig and there's no start, there's no shutdown. With automation, we can still keep the cost very, very low. And I'll touch on the numbers in a minute. Automating all of our aluminium cutting and assembly here means that we can keep the costs very competitive with what they can currently do in China. We can have really strict quality control. So BIPV products in the past have failed. Being integrated into the building means that it's a lot hotter. But going to a manufacturer with a 2 gigawatt line saying, hey, I want you to make 10 or 20 megawatts a year of my product, they might be like, well, we don't want to work with you. Okay, so then you've got to go down the supply chain and you've got to keep going tier 2, tier 3, tier 4, and you've got to go really low quality manufacturers with no quality control processes. Now, we've been very lucky in the relationships we've got with our solar tile, but if you go that far down the line, you're not going to be getting the quality components. There's going to be a lot of hand-done manual labour involved in making those products. So you're starting to see big failures of existing BIPV products because there's no quality control in these plants and it's very hard to manage. So the quality improvement we can have by doing it here means that we're not just making an Australian-made product using really good technology, but we're managing the quality really, really well. Maintaining IP in Australia is really big for us. So as we evolve and redesign and improve our product to get the cost down, we're also looking to maintain and keep all the IP here and export around the world. An example is that the 30% tariffs in the US on solar modules. We won't have that. The US is a very large market for us. I was just over in the States just after the New Year's, and it's incredible. Everyone was screaming at me for the product. I was in the line at Miami-Dade County. Miami-Dade is the strictest building product compliance in the US. So one of the sole purposes for me to go there was to take product and say, what tests do we need to do and how quickly can we do it? And I was standing in the line, I had two people come up to me and say, what's that? Is that a solar tile? And I said, yeah. And they said, how do I get it? I hate the look of solar panels. And so I gave my distributors details over there, and now they're getting quotes on systems. So there's this huge driver, and particularly in the US where they don't want to see solar panels on roofs, there's a huge driver for BIPV over there. So just that market alone could be huge for Australian manufacture and export. Yes, it's a long way for a container to go, but there's big opportunities to get around a lot of these issues globally. As I said, Australia's only manufactured export solar modules and a vertical manufacturing opportunity. Wouldn't it be great if we could manufacture cells here? That'd be pretty exciting, and maybe one day even ingots, or even new technologies that are getting developed and we could commercialise them here and then go out to the rest of the world. And, we've got companies like SunDrive that are making a really cool product. So these sort of things are really, really exciting, but without a large capacity of manufacturing here, and Volt won't be the only one, but if there is Volt doing 200 or 300 megawatts a year, and Tindo can grow to 200 or 300 megawatts a year, and then maybe a couple more manufacturers focused on that bespoke market where we can't compete with solar farms. And I develop solar farms, and Tindo's not bankable. I can't use their product. As much as I'd love to use an Australian-made product to my solar farms, I wouldn't be able to get the debt or equity providers to finance the project because it's not bankable. So we need to look at other avenues to increase the manufacturing capability here. Maybe we need a gigawatt. I mean, maybe someone here could do the study and understand how many gigawatts of manufacturing we would need to actually get vertical integration of manufacturing. There's a lot of opportunity here to do this, but without the first few steps, we're never going to get there. And then it's probably the last thing I'll touch on is our business case shows that we can manufacture our solar tile for 32 cents a watt cheaper than what we can in China, in Australia. 32 cents a watt Australian. Now that's a big, big cost saving. And then we can get around tariffs in the US, and we can be selling an Aussie product, and everyone loves an Aussie product. So that's our plan to manufacture, and I hope that the information I've given you has helped you understand a bit more about how we develop BIPV technologies and where the energy should be put. We try to steer clear of architectural-only products and really focus on products that can bring benefit to the energy system and the environment. Keeping in mind two things I'm going to touch on. Sorry. There's an environmental and social cost to everything we manufacture. And the environmental and social cost for a facade is not just the cost of energy, but it's the cost of mining, the labour that went in to making those products. And this reflects back to batteries. I'm a big believer that I don't believe in residential stationary batteries. I think the environmental impact and the social impact of the lithium mining is a disgrace that we're putting in and promoting through governments these 14 or 10 kilowatt hour batteries going in homes, and they're not optimised. The capacity factor is tiny because they're not getting the energy throughput, they're not getting the network benefits, they're not doing FCAS, they're not doing energy arbitrage. Yet we know that we need to transition, and we've got this huge shortage of lithium. Lithium shares, they're volatile, but they're always going up. So we've got this huge shortage of lithium globally, and we've got all these supply chain issues with modern slavery, yet we're still installing these batteries where they should be more focused on utility, where they've really got a benefit, and vehicles. And if we can stop putting them in homes and start putting them in vehicles and utility, we can stabilise the energy system. We can increase uptake of renewables. We can get more electric vehicles on the road. And then when we're allowed to do vehicle to grid, that's when the batteries in the homes make sense, that you can charge at work during the day and drive home and use that power, or vice versa, however it might be. So I'm a big believer that there's a bigger impact than just the cost of something and how we calculate the levelised cost of energy. That's it.
Thank you, Peter, for the interesting talk. And I can see the amazing solar tile product. That's very amazing. We can take a few questions. We can take a few questions from the audience. Do we have any question? Yeah, we can see Torsten.
Yeah, thanks for a great talk, and it's exciting to see your enthusiasm about manufacturing in Australia. It happens everywhere in the world now, in Europe and in the US, so yeah, it'd be interesting to see how that all unfolds. But I have a specific question on the cells that you're using. Mm-hmm. A lot of people, manufacturers, struggle with the constant change and evolution of cell designs, cell sizes in specific. The wafer sizes have gone up, and I could imagine that could be a potential problem for you if all of a sudden Chinese manufacturers, and they do this from one year to the next, they change from 156 to 162, then to 168, now 182 to 210, and next to 230. Yeah. That would potentially be a problem for a product like this.
So I didn't touch on this in my presentation, but supply chain security, supply chain risk is huge for us. And so not only do you have the political issues and COVID and all this sort of stuff and shipping, but you've got technology advancements. Now, as the standards in Australia are not designed or even consider building integrated PV, nor does the manufacturing of cells. And so the cells are getting bigger and we've got a very limited footprint that we can go to. So we can mitigate that through cutting cells and rotating the cells around. But again, it's going to change the efficiency of our product. If we start using a slightly larger cell, our product would go from 19.5% efficient down to 14 or 13. And therefore our cost is going to skyrocket because a large portion of the cost is in the framing and the extrusion and the manufacturing of that product. So it is a big risk, and it's something that is going to be mitigated, slightly mitigated, not fully mitigated, by manufacturing here in Australia. But then also about those advancements in technology. So our aim is to set up a manufacturing plant and be operational by end of 2024 or start of 2025. Right now we're just developing, and we're a technology company around integration into roof spaces or onto building facades. Where we need to go after that is the technology in cells. So we need to start working, I think I was saying earlier, working with universities to adopt the newer cell technologies and integrate those into roof spaces. At some point in the future, we will be printing these things and it'll make it a lot easier. But until that point in time, we're completely governed by the cell size.
Yeah, because if you say you need to be more vertically integrated, then you talk about actually becoming a cell manufacturer as well. And if you want to be that, you need to be a wafer manufacturer as well and ultimately make ingots. So yes. You're talking about actually covering the entire value chain.
And how many gigawatts do we need in this country to do that? That's the big question. Yeah. Because we've got the energy. We've certainly got more energy than anyone. And we're talking about making hydrogen and putting it on a boat and shipping it overseas. Like it's like the gas that just never existed. I've got uses for hydrogen, but it's certainly challenging if you want to ship it overseas. And so is there more challenges to ship billions of dollars of hydrogen overseas? Or is there more challenges to set up ingot manufacturing here? I don't know, it's a question.
Okay, thanks. More question?
Hey, Mr. Leeson, thank you so much. I have a doubt. So now solar panels, they produce a lot of heat. So don't these tiles, the roof tiles, increase the energy demand in the envelope, and are you facing any issues with that? So
there's a number of different things around here, and reflection of roofs is becoming big. So, a lot of estates now, it's light coloured roofs. And so and we absorb energy as part of the roof. So if you're 19.5% efficient and you're absorbing what would be transferred into heat, 19.5% of that energy from the sun out. The envelope of the building, yes, our solar tiles do run hotter than a standard panel because they're in the fabric. Any building integrated material will run hotter, and then you've got to calculate with the temperature coefficient the loss in generation. So anyone who says a solar tile will generate as much electricity as a solar panel with the same efficiency is a lie. You're always going to generate less. Other products that we've tested have been 18% less power, and that's because they've had a high thermal mass. So plastic solar roof tiles with a high thermal mass retaining a lot of heat, the cells remain hot and you get less power generation. Our product's aluminium and glass, it dissipates the heat, it's very light. Other products on the market, a 47 watt solar tile weighed 12 kilos. Ours weighs 10 and it's 115 watts. So we've got really low thermal mass, but ultimately you can't do anything about the integrating that building fabric. You want to put the cells in so you can't see them, you're going to have to cop that you're going to generate less electricity. But in terms of the roof space, there's a number of different ways. I'm currently building a passive house, so it doesn't affect it at all. You've got to look at the conversion of, as I said, with the energy. If you've got sun hitting those solar tiles, you're converting 19.5% of that energy into electricity. So you're not getting as much heat in there, but you've got more transfer of heat than you would with the different tile product. So, you can put whirlybirds on the roof to ventilate the roof. You can do a range of different activities to mitigate that. It's not a significant issue, but I'm also not a building designer, so, I can't fully answer that question.
Okay, question? Okay.
Thank you for your presentation. Just curious, the system you showed us, 5 kilowatts, was that $16,000 or something? 13. What roof size would that take in square meters?
So 5 kilowatt system, a 5 kilowatt system will go on most standard homes. Square meters, you're pushing me, I'd have to work it out, but I think it's going to be 19.5, so you're 195 watts per square meter. You make me do math. You're going to be about 26 square meters, I believe. Don't quote me on that. I'd have to get the calculator out of solar tiles. But it's basically going to be almost exactly the same size as a standard 5 kilowatt system. The standard panel is about 21.5% efficiency. We're 19.5 for our Lodge and 18.8 on our Platinum. So, if you're talking about peak power on the roof, about the same.
Second question, for that, the LCOE you showed us was for simplified no maintenance. And how does that change with maintenance?
Well, solar products aren't really required to do much maintenance. So it's not so much the solar tile or the solar panel. They're designed and life cycle tested and so on. It's the inverter. So you need to clean modules. The Clean Your Council recommends every 12 months. I've sort of pushed that out to 24 months. Realistically, if you've got gum trees sitting over your roof in your very dirty area, you want to give them a hose and a brush down every once in a while, but it doesn't need to be that common. The maintenance is in checking the electrical system, making sure the inverter's working, and replacement inverter after 10 or 15 years. But realistically, I was having a conversation earlier today, solar analytics. So solar analytics will tell you when your system's not working. The inverter technologies are getting really good that you can actually see when something's gone wrong with your system. So the actual, the truck rollout, the call out of maintenance is the main cost, and that's disappearing very quickly. For higher quality systems. Low quality systems, cheap panels, cheap inverters, they break down after 2 to 3 years and the system gets replaced. Because unfortunately we've got really high rebates from the government, and it's cheaper to replace the entire system with another cheap system, claim a new rebate, than it is to buy a quality inverter and fix the system.
Lily first.
Thanks, Peter, for the presentation. A quick question. So the installation of the product is a very complicated process, and it need to involve the roofer, the electricians. How did you overcome the barrier of certifier? Because in the end, we need to have someone to certify that everything is fine, so that we can get the OC.
No, great question. So yes, it's more complicated to install a BIPV system than just installing the building product and solar separately. However, our product is much easier to install than the previous BIPV system. So our business has installed probably 300 solar tile systems in Australia, of other products, which is we're probably the largest company to do BIPV in this country. And the other systems would take 2 to 3 times longer to install, very clunky and heavy. And we've improved that process by having the cable containment systems, our interlock. So the system's installed perfectly, because just like plugging an MC4 connector and hearing it go click, you hear our solar tiles actually click into each other, and you can visually see that it all goes in together and works perfectly. Now the roofing company, they also know that it's installed correctly, because if that interlock's not done, we don't sign a warranty on that product. So through our software, we actually manage reports. So every vault system installed in Australia gets a vault certificate, and that vault certificate means it's been audited with the photos and everything's done on site by the electrician, and then Bristile signing off on it as the roofing contractor. Or alternatively, we work with other roofing businesses that install Bristile roof tiles and they do the same thing. So a bit of software and a bit on the technical design side of things. But to touch base on like building compliance, let's say you're installing a standard panel system on a brand new home with roof tiles. So what happens is the roof is installed, gets done, and then the solar contractor shows up. They lift up roof tiles every 800 millimetres to a metre. They flip it over and they grind a big hole in the bottom of that tile, and then they screw a bracket through the sark and into the roof, and then they put that roof tile, and then they do that 120 times, and then they put a mounting system on, and then they put a panel on. And that roof has no warranty now because they've got big holes through every third or fourth tile. And so that's something that, and then you get roof leaks. And who's given the warranty? A very small solar business, not the ASX listed business that installed that roof. So on the other side, and I always say to everyone, in 10 years' time, we'll be saying, oh, remember when we used to go out and cut holes in roofs and put solar panel systems on? Wasn't that funny? Now we just put something that integrates and it's fully waterproof. So we're focused on obviously reducing things that don't need to be there in the system and making sure that there's an easy way to make sure it works and is compliant. And we've done dynamic weather tests, uplift tests, all this sort of stuff to show that we pass at certain pitches and that sort of thing as well. So wind tunnel, 120 kilometre winds, rain getting driven into it vertically, horizontally, and then so we've done all those tests as well.
Okay. Okay, we have the last question.
Thanks, Peter. That's an excellent talk. I have a question about the solar facade. You just showed it's not visible at this moment.
Yeah.
But if you break down the cost, you see part is due to the nature of the product or the process. It's just complicated, more complex.
Yeah.
But on the other side, it's probably due to the not yet streamlined protocols, like standards.
Yeah.
So in the future, if you think, imagine the other side, the man-made side, or the political side of the cost structure is solved. Do you think it could be viable in the future?
Yeah, I think so. Let's talk about parity of electricity costs from. So I remember maybe 4 or 5 years ago, all the media was saying parity. We've hit parity with grid costs of electricity, like from solar and from wind, and now we're far lower. So let's talk about building product parity. So you get an Alucobond facade on a building and it costs you $270 per square metre. And then we can install a solar facade at $220 a square metre. There you've got a business case. So you're starting to generate electricity, which is revenue that can pay for the ongoing cost, maintenance and replacement of that product after 20 or 30 years. So there's definitely a market in time. I just don't think that we're anywhere near ready. And I think that it still remains architectural. So to get that cost down is going to be difficult. We do, however, have designs in our product where it's just like a tile, but it goes onto a facade, but it's more of a retrofit option. So what it is you've got an old factory, an old commercial facility, they want to do it up, and we believe we can get the cost around parity of a Alucobond. So that's like our Alucobond's our target sort of price, because that's what happens to a lot of commercial buildings. And once we can achieve that, we can sort of say, well, we've got a solution. I still think it's going to be very hard to scale though, because of the lower energy yield out of it, because you're ultimately still 50% below. And then what happens if a tree or a plant grows next to it, or you've got eaves on the building, and which way is it facing? And someone parks a car next to it, then you've got to put microinverters and you've got more hassle. So there's a lot of barriers there in terms of energy generation.
Okay, one more.
So I have a question regarding the solar cell arrangement. As you said, there's a 19.5% efficiency of volt solar tile. So what's the arrangement like? Are you using the shingling solar cells, or are you arranging it in the the tilling ribbon pattern as in the conventional modules?
So we're using a MWT cell, and I'm not a cell specific expert, so my explanation may not be technical, so don't criticise me. But an MWT cell's metal wrap through technology. So basically what it's got is a printed circuit board on the back, and it goes onto a conductive back sheet. So we could look at shingled. However, I'm, for the minute, steering very clear of shingling because I'm worried about impact and breaking of that glue. I think it's a great idea, and I think if it can be proven over years to come in real world conditions, we'll definitely start to use it because it's got a lot of advantages. The main one being colour, continuous colour right through the cell. So you can't really see the cells at all when you're talking about that. But yeah, at the minute we're using MWT. When we move to Australia, we won't be using MWT. We'll be using a type of PERC cell, but we don't know yet.
Okay, thank you. With that, I think we don't have time left. We thank Peter again. Thanks for the talk.